Hello students. So in this class we are going to learn about functions. So what is the definition of function and what is the difference between relations and functions? So a function f from a set A to a set B is a special relation. Function is also a relation, but it is a special relation. A function f from a set A to a set B is a special relation in which every element of set A has unique image in set B. So what is the important point here? A function f from a set A to a set B is a special relation in which every element of set A has unique image. Remember it, unique image in set B. Correct? So, and how we denote a function? The function f from A to B. The function a from A to B is denoted by f double dot A arrow B. It means the function f from A to B. The function f from A to B. If fa is equal to b, then b is called the image of A under f. If fa is equal to b, then b is called the image of A under f. If f of A is equal to b, then b is called the image of A under f, and A is called the pre-image of B under f. Just see, there is an equation like y is equal to 2x plus 1. Correct? So when x is equal to 1, then what is the value of y? So y is equal to 2 into 1 plus 1. That is 2 plus 1. That is 3. The same thing we can represent as y, or this y we can also write like this: f of x. F of x means function of x. So y is a function of x, and that is equal to 2x plus 1. So the same thing we can write it as follows: f of 1 is equal to 3. Correct? So f of A is equal to b, then b is called the image of A. Means this 3 is the image of 1. 3 is the image of 1 under fx is equal to 2x plus 1. If this is the function, then 3 is the image of 1 under function 2x, fx is equal to 2x plus 1. And on the other way, we can call it that 1 is the pre-image of 3. 1 is the pre-image of 3 under f. 1 is the pre-image of 3 under fx is equal to 2x plus 1. Correct? So this is very clear now. If f of A is equal to b, then b is called the image of A under f, and A is called the pre-image of B under f. Come to the next slide. So now the definition of function one more time. Okay. So a function f from a set A to a set B is a special relation. This is a special relation in which every element, see here, this every term is very important. Every element of set A means all the elements of set A should be used and has a unique image in set B. Means every element of set A should be only one image, unique image in set B. So now, as per the definition, we have to find that there are 3 examples: example 1, example 2, and example 3. So what are now we have to see that what are the functions. 1 is a function or not, 2 is a function or not, and 3 is a function or not. Correct? So first of all, we see that if there is a relation from x to y, there is a relation from x to y, then is this relation a function? We have to check. See here, if A is the pre-image, what is the image of A1? What is the image of B2? What is the image of C? No, it is not related. Means every element of X should have unique image in set B. So here all the elements of set X is not utilized. So this is not satisfying as a function. So this is not a function. This is not a function. What is the reason? Because set all the elements of set A are not having image in unique image in set B. This is left. Correct? So this is not a function. Now we'll come to C, the second option. See here. What is the image of A1? What is the image of B2? What is the image of B3? What is the image of C? Image is having no image in 3. So this is failing on two accounts. First account, because C is not used. So that is why it failed. Another, every element in set X should have only one image in B. But here the B is an element in X which is having two images, 2 and 3. So this is also not satisfying as a function. So this is not a function. Now come here. See, there is a relation from X to Y. Now we have to check that whether this relation is a function or not. See here, A is related to, means what is the image of A1? What is the image of B2? What is the image of C2? So on first hand means all the elements of set X has been used in the relation. Okay. So this is yes. On this account, it is a function. Now every elements of set X should have a unique image in set B. Yes. A is having a unique image, that is 1. B is having a unique image, that is 2. And C is also having a unique image, that is 2. Correct? So this is satisfying as a function. So this is a function. Yes, it is a function. Just see carefully here. B is having a unique element in set Y, that is 2. C is also having a unique element in set Y, that is 2. So that is correct. Here in this case, the B element of set X was having 2 images. So there should not be more than one image. There should be unique image, means only one image. So see here, B is having 2 images. So this is not satisfying the conditions of functions, but this is satisfying because B is having a unique image in set Y, that is 2, and C is having a unique image in set Y, that is also 2. So this is okay. So this is satisfying as a function. This is a function. Now see here in this example. In the following diagrams, which of the relations are functions? Okay. So this is the example number 4, 5, and 6. Here, X is a relation from R is a relation from X to Y. R is a relation from X to Y. Okay. Now see here, the element A is having a unique image in B, that is 2. B is also having a unique image in Y, that is 2. And C is also having a unique image in set Y, that is 2. And all the elements of set X has been utilized here. And all the elements of set X means A, B, and C are having unique image. So this is okay. Yes, this is satisfying as a function. So this is a function. Whereas this is not a function. Why? Because A is left, C is left, means 2 elements of set X are not utilized. And then B is having 3 images. B is having image as 1. B is having second image as 2. B is having a third image as 3. But as per the definition, a relation is a function only when all the elements or every elements of set A has unique image in set B. So here the B is not having unique image. So it is failing. So it is not a function. Now come to the example 6. So R is a relation from X to Y. Now we have to check that whether this relation is a function or not. See, what is the image of A? 1. What is the image of B? 2. What is the image of C? 3. And all the elements of set X has been utilized here. Correct? So A is having a unique image in set Y, that is 1. B is having a unique image in set Y, that is 2. And C is also having a unique image in set Y, that is 3. So this is also satisfying as a function. So this is also a function. Correct? So this is a function. So yes, 4 and 6 represent functions. Now see here, there is one example. There is a question. Let A is equal to 1, 2, 3, 4, 5, 6, means 1, 2, 3, 4, 5, 6 are the elements of set A. Define a relation R on A by R is equal to X, Y such that Y is equal to X plus 1. Means Fx is equal to X plus 1. Okay. So write down the domain, codomain, and range of paths. So as per the definition, so what is the domain? Domain of a relation. So first of all, we'll write all the elements in. This is the first set. This is the second set. And here, because the relation has been defined on set A only, means it is A cross A set. So all the elements are same. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. Now Y is equal to X plus 1. So Y will be represented by the second one, and X will be represented by this one. Correct? So what is the domain? Domain means all the elements of set A which are taking part in relation. So here in a relation, this 1, if you take X is equal to 1, then it will become 1 plus 1, 2. So 1 is related to 2. Similarly, if X is equal to 2, then Y will be 2 plus 1, 3. So 2 is related to 3, 3 is related to 4, 4 is related to 5, and 5 is related to 6. 6 is not related to anybody, because the elements is the highest element in the set is 6 only. So only these are taking part in relation. So what are the elements of this relation? The elements of this relation will be 1, 2, 2, 3, ordered pairs, 3, 4, 4, 5, and 5, 6. So this is the set A cross A. Here, this relation means these are the elements of from Cartesian product of A by A. We have defined this relation. So here R is equal to 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. So see here, the elements, first elements, the set of first elements will be called the domain. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 is the domain. Okay. And what is the range? Range means all the second elements, 2, 3, 4, 5, 6. This will be your range. And now what is the codomain? So codomain is the elements, all the elements in the second set. All the elements in second set are taken for codomain. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So these are the elements of the codomain. These will be called codomain. Now, since the element is now, this is a function or not? See here, one element is left here. Our definition is what is the definition of a function? Every element in set A should have a unique image in set B. So here, this 6 is not utilized. So this is not satisfying as a function. So this is not a function. So this relation is not a function. Come to the next one. Okay. Now the types of functions that we'll see later on. But one more thing, whether a relation is a function or not, there is one more important point, and that is called the geometric test or vertical line test. That also we are going to see here. Just a minute, I will. Okay, so algebraic test for functions. So this test we have already seen. algebraic test for functions. Suppose a relation is given as an equation if the substitution of any value for x results in at most one value of y, means unique image. Then the relation is a function. Yes. What is function? Function is a special relation in which every element in set A has a unique image in set B. The same thing here written in a different language. Means suppose a relation is given as an equation if the substitution of any value for x results in at most one value of y, means unique, only one value of y, then the relation is a function. See here, for example, y is equal to 3x minus 1. Whether it is a function or not, so just put x, you put x for any value. If you are putting x is equal to 1, then y is equal to 3 minus 1, 2. If x you are putting as 2, then y is equal to 3 into 2, 6 minus 1, that is 5. So so whatever value for y you put here, you will see that y you are getting a unique value for y. So this is a function. Since for any value of x there is only one corresponding value of y, so this is a function. Yes, this is a function. Now see the second case, x is equal to y square. So when x is equal to y square, it means what? X is equal to y square. If x is equal to 4, 4 is equal to y square. It means what? Y is equal to plus minus 2. Are you getting? It means x is equal to 4. X is equal to 4. Then y is having two value, plus 2 and minus 2. It means the this element, whatever element you are choosing for x, it is having not a unique image in set B. This gives the element of set A and this gives the element of set B. It is having two values. So here we are not getting a unique image for a value of x. So it is not satisfying as a function. So this is not a function. So x is equal to y square is not a function. Since if x is equal to 4, then y is equal to plus minus 2. Now geometric test or vertical line test for functions. Suppose we draw all possible vertical lines on the graph of a relation. If each line cuts the graph at most once. See, this is very, very important too. If we have drawn a relation on a graph, then it's a very easy way to find out that whether that relation is a function or not. So suppose we draw all possible vertical lines on the graph of a relation. If each line cuts the graph at most once, then the relation is a function. Yes. If each line cuts the graph at most once, then the relation is a function. But if at least one line cuts the graph more than once, if only one line cuts the graph more than once, then that relation is not a function. Means that value of x is not having unique image in set B. If at least one line cuts the graph more than once, then the relation is not a function. Now we'll see it from the example. See which of the following relations are functions. So that we are going to see. What we have to do here? Just you draw vertical lines anywhere. If this is the graph, what you draw a vertical line. What you see that this vertical line is cutting this graph only once. So this is a function. Yes. Here also, if you draw vertical lines, that is why it is called vertical line test. Draw. Anywhere you draw the vertical line. What you see? It is cutting the graph only once. So this is also a function. See, now see the third case. Here you draw the vertical line. What you see here? When you are drawing vertical line, this vertical line cuts this graph at 2 points. Here and here. Here also. Correct? So this is not a function. Not a function. Because for a single value of x, just imagine that if it is 2. For 2, you are getting here plus 4 and minus 4 or something. Whatever value you are getting. For a single value of 2, for single value of x, when for x is equal to 2 in the graph, you are getting y is equal to plus 4 and y is equal to minus 4. Means it's an example. So you are getting two values. Okay. So it means for x is equal to 2, you are not getting an unique image. For y, you are getting two images. So that is why it is not satisfying as a function. So this is not a function. Correct. So this is a function. Yes, because this vertical line cuts only once. This is also a function because it vertical line cuts only once. Here, see, it is not a function. If only one line also cuts the graph at more than once, it means it is not a function. It is not required that all the points, all the vertical lines should cut the graph more than once. Well, if only one line, if only one vertical line cuts the graph more than once, then also it is not satisfying as a function. So it is not a function. Correct. So now think with this example, the function idea of function is very much clear. So now we'll meet in the next class and we'll see the type of functions. Okay, so we'll stop our class today here only.